Good morning, friends. Today we are going to continue for the impact of the jets, and in that today we are going to cover about the force exerted by a jet on a stationary curved plate. That curved plate we are going to assume to be a symmetrical plate. Okay, so now let's assume that this is an curved plate which is stationary and held in the position by the anchor bars. Those are provided at its ends. Suppose that this is a one of the anchor bar and this is the another one anchor bar. Now it is acted upon by a jet. So suppose that this is a jet of the water which is moving with a velocity of v having the diameter as a small d. Now consider that the tangents are drawn at its both the ends or both the tips, we can say. So those are the tangents and they makes an angle of theta degree with respect to the x axis, that is the axis of the jets. So now what is going to happen over here in after striking the jet at the center of the plate, it is going to deflect. So we'll consider that after striking the plate, the water will glide over the surface of the plate and it will deflect or it will move towards the tips of the plate. As the plate we are going to assume to be as a smooth, as there is a no loss of the head or the friction is not present over therein. So the water while moving out of it, its velocity will be the same as that of the velocity of the incoming jet. Consider that this is the angle of deflection of the jet, that to be 180 minus theta degree, and it will be on both the sides as it is a symmetrical one. So now after gliding over this surface, the water will have the angle of 180 minus theta degree at its tips. So this will be the velocity phi, we can say, and it will have the angle of theta degree with respect to the horizontal, which is the angle of tangent drawn at the outlet tips with respect to the horizontal. As water is coming out of the tip, it means that the velocity will have the angle that of the tip with respect to the horizontal. So now by resolving the velocity, it will have the two components. One will be along the x-axis, that will be phi cos theta, and another will be along the y-axis, that will be phi sin theta. Okay, now we have to find out the force exerted by this jet on this plate at its center. So consider that this is the force F, rather Fx, at it is acting along the x-axis. So we have to correlate that force with respect to the volume density or the velocity and angle theta, so that we will get the magnitude. Now as after striking the plate at the center, the momentum of the jet or the momentum of the water is going to change. So using the linear impulse momentum principle, so by linear impulse momentum principle, so what it tells about, it tells that the rate of change of momentum in the direction of the force is directly proportional to the applied force, or it is proportional to the impulse in the same direction. That is, force into time is equals to change in momentum in direction of force. Now here direction of force is the direction of a jet, we can say. So rearranging the terms, we will get the force into time is equals to change in momentum. Momentum is nothing but the mass into velocity. So that is change of momentum, we can say, that is a initial momentum minus final momentum. So now rearranging terms once again, F into T is equals to mass into initial velocity in direction of jet minus final velocity in direction of jet. Okay, so that is force F into x is equals to m upon t into initial velocity of jet in initial velocity of the flow in the direction of jet is a phi, that is a phi as usual, minus final velocity of a flow or the jet in the direction of the jet itself is now deflected, that is the water after striking the plate is moving in the opposite direction that of the direction of the jet. It means that this phi cos theta is the component of the velocity along the jet that to be in opposite direction, so we have to consider it has to be a negative one, that is a minus phi cos theta. So that is will be fx is equals to, now converting mass in terms of the density, that is density is equals to mass upon volume. So we'll get the mass is equals to density into volume, volume per unit times the discharge, discharge is area into velocity. So we'll get the equation as density into area into velocity, whereas area is area of cross section of the jet and phi is the velocity of the jet. So rho av into phi minus minus plus phi cos theta, that is equals to rho a phi square into 1 plus cos of the theta. This is the magnitude of the force exerted by a jet in the direction of its own direction when it strikes on the symmetrical stationary curved plate at its center. Okay, now we will see the conditions. Suppose that this is equation 1, when angle theta will be equals to 0 degree. Now what is the condition? That the theta is a 0, means theta is a 0. It means that plate will have the shape like this, a directly a U-like shape we can say. So this will be the jet and this will be the our plate. So this angle will be directly a 0 degree, and this is the incoming velocity phi will be there, and this will be the outcoming velocity phi will be there in. Okay, so now in this case the equation 1 implies fx is equals to rho a phi square into 1 plus cos of 0. As cos 0 is 1, so we will get fx is equals to 1 plus 1 as 2, 2 times rho a phi square. So it means that when the angle theta is a 0 degree, in that case you will get the force exerted by a jet on the plate is 2 times the force exerted by a jet on a stationary vertical plate. Okay, as already we had seen that for the stationary vertical plate, the force exerted by a jet on it, if this is the velocity phi, this is the vertical plate and this is the velocity phi, then this force F is equals to rho a phi square. That part we have already seen. It means that this is exactly equals to the 2 times when it is going to bend by a 90 degree to the left hand side, or for the curved stationary plate if the angle theta is a 0 degree. Okay, now we'll discuss about the some of the numericals related to the same. Let us consider a jet of water of diameter 40 millimeter moving with a velocity of 30 meters per second strikes a curved symmetrical plate at its center, and we have to find out the force exerted by a jet on a plate if it's in its direction if the jet is deflected through an angle of 120 degree at the outlet of the curved plate. Okay, so we'll firstly write down the given data, the terms those are given to us. So here they had given to us the diameter of the jet as 40 millimeter, that is equals to 0.04 meters. Then its area of the jet will be a is equals to, as it is circular, so pi by 4 d square, and after putting the values you will get its magnitude as 0.001256 square meter. Okay, and again they had given to us its velocity phi as 30 meter per second. Okay, then angle of deflection, That means suppose that the condition is like this is a jet and this is a plate, okay, and this is the deflected water which is coming out of it. This is the velocity v, this will be again a velocity v, and it will have the components like this. This is the velocity v, so this will be angle theta. We are going to assume that the tangents makes an angle of theta with respect to the horizontal, and they had given us angle of deflection. This angle is given to us, that is a 120 degree. So therefore a theta will be equals to 180 minus 120, that is equals to 60 degrees. Okay, now by considering those things we have to find out to calculate. They have asked us, that is a force exerted by a jet on the plate at its center. So this will be center and this is the force apex. Now we know that the force apex is equals to rho a v square into 1 plus cos of the theta. Okay, so now by putting the values, so herein after putting the values you will get the magnitude of the force fx is equals to 169.169.5, that is 1695.6 newtons. I have quoted the values directly herein as I have considered this as one of the standard solved examples.